In Chapter 13, we're going to discuss the chemistry of dienes and the allele system. So let's look at a brief preview of what we're going to be talking about in this chapter. One of the things that we're going to see throughout is understanding the difference between conjugated dienes and non-conjugated dienes. Now, as the name implies, a diene is an alkene, a molecule that has two double bonds. So, in general, non-conjugated dienes have an sp3 carbon that separates the two double bonds. So let's look at a couple of examples of non-conjugated dienes. The first example is 1,5-octadiene. And you see in this structure, obviously you have two double bonds, and if we think about the hybridization of the carbons of the double bonds, we know that they're sp2 hybridized, and we also know that each carbon has a p orbital, and so a double bond is formed from two electrons in the overlap of those two p orbitals. In between the double bonds, though, you have these sp3 carbons, and because the carbons are sp3 hybridized, they do not have a p orbital, and so you can't have a delocalization of electrons, and that's one of the main aspects of conjugated dienes is a delocalization of the pi electrons. And so we can look at some more examples. Here I have, this is 1,4-pentadiene. And again, you see in between the two double bonds an sp3 hybridized carbon, right? So that sp3 hybridized carbon interferes with the delocalization of electrons. And then lastly, we can even look at a cyclic diene. Obviously, this is also not a conjugated system. And this is called 1,4-cyclohexadiene. And you see that there is an sp3 carbon in between the two double bonds. And so because of that, it is not conjugated. So what does a conjugated diene look like? This is the simplest conjugated diene. The name of this is 1,3-butadiene. And you'll see with 1,3-butadiene, all of the carbons are sp2 hybridized. And because of this, you have p orbitals. All the carbons have p orbitals. And so those electrons in those p orbitals can overlap with one another. We say they can be delocalized. And we're going to see the chemistry of that later on in this chapter. A couple of other structures. This is 2-methyl-1,3-butadiene, also conjugated because there is no sp3 carbon separating the double bonds. Here I have 1,3-pentadiene. Again, the two double bonds have no sp3 carbon separating them. And of course, here's a cyclic butadiene. This is 1,3-cyclohexadiene. And again, between the two double bonds, there's no sp3 carbons. Right, so they're all sp2 hybridized. Now, why do I bring this up? Why do I bring up the difference between conjugated and non-conjugated? The biggest thing is that conjugated dienes are so unique that they are classified as a separate functional group. And we're going to see that uniqueness played out in the rest of the chapter.